So you can use switch statements to look up the type of a value and then define different cases for different types. There also is an alternative syntax you can use for looking up a value type. You can use that value for which you want to look up the type, and then use the dot on it. And this works no matter if the value is a struct or any other kind of value, because after the dot, I'm now not trying to access any field, like name. That of course would only work if this were a struct with a name field. But instead, we again use these parentheses, just as we did it here. But then we don't type type between those parentheses. That indeed only works inside of a type switch statement and not outside of it, as you can tell by this error. But instead we can type a specific type name for which we're looking. For example, int. And if you do that, you will actually get back two values from accessing this special type field here, so to say. You get back the typed value, and you get back a boolean that tells you whether this is of that type you have between those parentheses or not. So OK, or whichever name you want to use here for this second value, will be true if the value is of this type you have between the parentheses, so if it's an int in this case. And typed val will be that value, but at this point here, when we store it in that separate variable, which we create after accessing this special type field, at this point, Go knows that it will be an int. So thereafter, you can work with it as an int. Keep in mind that value can be any type. So for example, if you're trying to use value to add a number to it, you will get an error because we got mismatched types. Because Go essentially complains here that value could be any type and it doesn't know if the plus operator exists for that type. If we on the other hand use typed val here, we'll just get the error that we're not using the result of this calculation, but using the plus operator is fine. And that's the case because typed val will be an int after running this check. Now it might be 0, so the null value of an int, if value turns out not to be of type int and OK holds false. So therefore you want to check if not OK, which simply means OK holds a false value, and in that case you could do something else. Or you check if OK, so if that type check here indeed does return that value is of type int, and then in there you could safely use that typed value in the way you want to use it, because at this point you know with certainty that this will be an integer and that it's the original value that will be an integer. So then here I could, just as before, output by value, but here I could now also use typed val. Here it doesn't really matter in this specific case because println doesn't care about the type of value, but if you were in a situation where it matters, typed val will be of type int. And now we could of course use that same logic to check for the other types as well. So here I'll actually rename this to int val so that I can use different names for different types. And then we can copy this logic and also return here, so that no other code gets executed thereafter. And then I copy this logic, and thereafter I check if the value is of type float64, for example. And I'll name it floatval. And then I can output float and the float value. And thereafter we can of course also check whether it's a string. So we can check if it's a string val by using string here between those parentheses. And then here we can output string and string val. Now, of course, the switch case statement was more compact, more concise, but it's worth noting about this syntax here Also because we'll use later in the course when we build that REST API, and because it can simply be very useful if you have a situation where you're getting a value that could be of any type and where you're then maybe looking for a very specific type and you want to execute a very specific action for that type. So that's therefore a syntax you should know.